Welcome to Get Your FRQ On. This is from the 2015 exam. It's question 4, and it is not calculator active. In part A of the problem, we are asked to sketch the slope field for a given differential equation, dy dx equals 2x minus y, for the 6 points provided. For any slope field, you're just going to take the points that are provided on the graph, and you're going to plug the coordinates into dy dx, figure out what the slope would be at that point, and then draw a tiny little segment that has that approximate slope. All right, if we do that here, we get a slope field that looks like this. All right, so the 6 points are 0, negative 1. So if x is 0 and y is negative 1, 0 minus negative 1 is 1. Notice this little segment down here has slope approximately 1. At the point 1, negative 1, 2 times 1 is 2, minus negative 1 is 3, so this slope right here is 3. And these don't have to be perfect, just make sure that they're close, right? You don't want your slope of 1 to look like it's more a slope of like 1/5, like don't do that. But then they also have to be kind of accurate relative to one another, like your 1/2 shouldn't be more than your 1 for a slope. So as long as it's reasonably accurate, you would get the points for however many points this part would be worth. All right, part B, we are asked to find d2y dx2, the second derivative with respect to x, and then determine the concavity for all of the differential equation solutions in quadrant 2, and then also to provide a reason. All right, well, the second derivative is just the derivative of the first derivative. So if we differentiate 2x minus y, we're going to get 2 minus dy dx. We already have a rule for dy dx. It's 2x minus y. So the second derivative is just 2 minus 2x minus y, which is y plus 2 minus 2x, or however you want to write it, as long as it's correct. There's a number of forms you could have here. All right, so in quadrant 2, x values are negative, y values are positive. So if y is positive, a positive number plus 2 is just more positive. If x is negative, negative 2 times a negative number is more positive. So in quadrant 2, we would have that all values of d2y dx2 would be positive. So in quadrant 2, if all values of d2y dx2 are positive, it would have to be the case that the solutions in quadrant 2 would all have to be concave up. In part C, let f of x be the particular solution to the differential equation such that f of 2 is 3, and then we are asked to determine, does f have a relative minimum, a relative maximum, or neither at x equals 2, and to provide justification. All right, well, if f of 2 equals 3, then dy dx at the point 2 comma 3 can be evaluated simply by plugging it into the formula for dy dx. And that formula tells us that dy dx at the point 2 comma 3 is 1. Notice that 1 is not equal to 0. And from this we can conclude that f of x has neither a maximum nor a minimum at x equals 2. In part D, we are asked if y equals mx plus b is a solution to the differential equation, find m and b. Okay, so let's suppose that we have a solution to this differential equation of the form y equals mx plus b. In other words, it is a linear function that solves the differential equation. Well, if it solves the differential equation, then the slope of that line, which is the derivative of that line, would have to equal our expression for dy dx, right? So m would have to equal 2x minus y. But if we're assuming that y equals mx plus b is the solution, then when I have y in my equation, I can replace it with mx plus b. So let's do that. So now I have m equals 2x minus mx plus b, right? I can factor out the x from the first two terms. So now I have 2 minus m times x minus b, and I want that to equal 0. I'm sorry, I don't want it to equal 0, I just want to simplify it. I want the m's on one side. All right, so if I subtract an m from both sides, I get 2 minus m times x minus the sum of m plus b. All right, and then we need to equate the coefficients. Remember that saying that this linear function is equal to 0 means basically that there's another line, 0x plus 0, which is equal to that line. And in order for that to be true, the coefficients would have to be the same. So we use this process called equating the coefficients. Well, in order for x times 2 minus m plus b to be 0, the 2 minus m would have to be equal to 0 all the time, and m plus b would have to equal 0 all the time. So we can use that to solve this equation. Right? Given the requirement that 2 minus m times x minus m plus b is equal to 0, m would have to be 2 and b would have to be negative 2. All right, so 2 minus m needs to match the coefficient of x in the equation, 0x plus 0. So 2 minus m has to equal 0, which means that m is equal to 2. Using m equals 2, we can conclude that 2 plus b has to equal 0, and that would only be true if b was equal to negative 2, so that's how we get our values of m and b. M is 2, b is negative 2.